works on a math equation, then never even ever really even is an or M. Finish by our creation, one pivots, tones, and then.
Good morning, class. I'm Mrs. Mulwark. Today we will be covering solving systems of equations by graphing. It's a very interesting lesson. Does anybody know what this means or how to solve a system of equations by graphing? Ooh, me. Yes, you over there, Laura. Yes, it's you. Me? Well, solving systems of equations by graphing is the point where the two lines, or many lines, where they intersect and the ordered pair that satisfies all of the equations by making them equal to each other. That's just great, Laura. You're just a great student. Now that we have covered the easy concepts, we're going to cover the difficult material now. We're going to cover the steps on how to solve systems of equations by graphing. The first step is to put the equation into slope-intercept form. This is y equals mx plus b, n being the slope and b being the y-intercept. Once you have the equations in slope-intercept form, you need to graph them. Once you have these graphed, you need to put you're going to need to find the intersection of the lines. The intersection is where the lines cross and the point at which they cross. Once you have the ordered pair of the intersection, you need to plug the x and y values into the equation to see if the solution matches up and if it satisfies the equation. We have gone over our boring material now, and now we are able to work on some fun equations from math by solving actual equations by graphing. How much fun is that? Yay! So our first two equations for this actual math problem is x plus y equals 4 and negative x plus 2y equals 2. So after previously taking notes, I would know that the first step on how to solve an equation by graphing is to put each equation into slope-intercept form. So for x plus y equals 4, I need to subtract negative x from both sides to get y isolated by itself. Now that I've done that, it got me to my first answer, which is y equals negative x plus 4. Now I need to do the same math to the other equation. I need to add x to both sides to get y by itself again. This gives me 2y equals x plus 2. Now, I can't just leave y with the 2 in front of it as its coefficient. I need to get it to be 1y instead of 2y. So I divide each side by 2, which gives me my answer, y equals 1/2 x plus 1. Now that I have my equations for slope-intercept form, it can get me to my next step, which is graphing them. Yay! Now that we have put each equation into slope-intercept form, we are able to graph. So here are my equations. Y equals negative x plus 4 and y equals 1/2 x plus 1. Once I graph these, I know that for the first equation, y equals negative x plus 4, the intercept is 4, the y-intercept is 4, and the slope is negative 1. So for every 1y, it goes up, the x value will decrease by 1. And for the second equation, y equals 1/2 x plus 1, I know that the y-intercept is 1 and the slope is 1/2. So for every 1 of y, the x value will increase by 1/2. So once I graph these equations, I know that the point of intersection is 2, 2. This gives me my solution to my graph, which is really good, which gives us step number 3 in plugging the equation, which gives us step number 3 by finding the point of intersection, and step 2 by graphing it all in one. How lucky are we? Now we're on our final step to solving systems of equations by graphing, which is plugging in the point of intersection from the recent step to the slope-intercept equations to see if we got the right solution. So since we know the point of intersection was 2, 2, the x value being 2 and the y value also being 2, and the equations were y equals negative x plus 4 and y equals 1/2 x plus 1, we can plug in 2 for both the y and x. And so, after we plug in 2 for y and x on the first equation, we know that 2 equals negative 2 plus 4. And since we know negative 2 plus 4 equals 2, 2 equals 2, which gives us the right solution for our first equation. But this has to be the right solution for our second equation if we want it to be the correct solution for the total math equation. So since we know that the y value equals 2, we plug in 2 for y and also 2 for x. So 2 equals 1/2 times 2 plus 1. And since we know 1/2 times 2 equals 1, 2 plus 2 equals 1 plus 1, which equals 2 plus 2, which gives us the correct math equation. The math solution, excuse me. See, isn't just learning with a great teacher like me, Mrs. Moorwork, just so much fun? And since we learn with me, learning math, overall, is just a great thing. Now that we have finished solving the systems of equations by graphing, we finished our equation in this. We need to check our solutions in the calculator because the calculator is always right. Am I right, Am I right, class? Okay, so now I have plugged in y equals negative x plus 4 into the calculator and also y equals 1/2 x plus 1. So now, after we do this, we click the graph button, and then we click second, trace, 5, and then we click enter 3 times. And then that gives us the intersection, which is x equals 2 and y equals 2, which is our solution that we got. So we are correct because the calculator is always right. And we are almost done with our lesson, but I need to cover one final material before I can dismiss you guys. I need to cover what one solution on a graph looks like, what no solutions on a graph look like, and what infinitely many look like. One solution on a graph from multiple linear lines looked like this because there's only one intersection. No solutions on a graph look like this because there's no intersection between the two lines. Infinitely many solutions on a graph look like this. This appears to be only one line, but there's two lines with the same equation. So any point on that line will give the correct solutions to the equation to satisfy it. Now I'm done with you guys for this lesson today, but the class isn't over for you guys. I need you guys to do a set of pages for homework. In the Algebra 2 textbook on Chapter 3, I need you to start on page 120, question 1, till the end of 121, question number 43. This will really help you guys in understanding solving systems of equation, and will give you guys extra practice to have more knowledge for this lesson. Goodbye, class. I hope you guys had a good time.